Ahora va a hablar el profesor Glenn Ballard, director del Project Production System Laboratory de la Universidad de California de Berkeley, cofundador del International Group for Lean Construction, director de investigación del Lean Construction Institute y creador de herramientas como Last Planner System, nada más y nada menos. Y nos va a mostrar los beneficios del Lean Construction pues, a través de un viaje de 6 casos de estudio. Así que, profesor Ballard, gracias por venir y por todo el respeto y ayuda que he recibido siempre de tu parte.
Yeah. Can you hear me all right? Good. Okay. So, and I do this. Got it. All right, so. Sorry?
You're not in presentation mode.
I know, I'm trying to get it there. There we go. Here we go. Okay. I realize that many of you, some of you at any rate, are listening to this through translation. And so if I'm going, although I don't see very many people listening to it through translation, a few, but if I'm going too fast, slow me down. Okay? All right. I also don't mind being interrupted. If you have a question that needs answering in order for you to continue listening, ask it. Will you do that? Is that acceptable in this culture? Interrupt the professor. That's what you should do. All right. Otherwise, we just drone on. Okay. I'm going to present a few cases, as Fernando said. They're not picked, they're not selected for any particular reason, although they're all interesting and important cases. But I selected them because I was involved in all of them. So these are cases from my own experience. So I can answer more questions than maybe would normally be true, right? So I'm hoping to get lots of questions. Here we go. Okay, this is, and they're presented roughly historically, although I violate that rule right here. This was from 1996. It's from a weekly work plan, the first last planner weekly work plan of Philip, who's a foreman of a pipe fitter crew on a wafer fabrication plant for Texas Instruments in Dallas. Yeah? You look puzzled already. Are you okay with it? You here? You. Okay. Okay. So let's just walk through it a little bit. So Philip is, where is it? So Philip's the foreman, right? And he produced this work plan for the week of 9/20/96, the September 20th, 96 in U.S. format. And what it says is that Silvano, Modesto, and Terry are going to install hangers, pipe hangers, in Building K for gas and fuel oil lines. And those are supports for the pipe, the risers that will be suspended from the ceiling in that building. Yeah? And they're going to do that. They're going to put in the hangers on Monday and Tuesday, and then they're going to install the pipe Wednesday, Thursday, Friday, and Saturday. Yeah? He's also got other sub-crews, Charlie, Rick, and Ben, who are going to work on the condensate water line for the first 3 days, and then chiller risers the rest of the 6-day work week. So you see what kind of a plan we have here? Yes would help. Yeah, okay. All right. So at the end of the week, what we asked Philip to do was to status whether or not he had completed these tasks, or his crew had completed these tasks. Yeah? And so we have no, no, yes, no, yes, 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 no, yes. And this is the basis for the metric, the measurement in the last planner system called percent plan complete, PPC. Yeah? And it's a very simple calculation. It says, what's the percentage of plan tasks that were completed, fully completed, completed to the point that the next trade could go to work? Yeah? So in this case, what's the PPC for Philip's first week? Anyone? 50? Roughly, it's probably about, it's 5 over 9, right? So it's about 55%, right? Yeah. So as it happens, I had done a research in the early 90s that looked at both the design and construction phases of multiple projects for 7 different companies, right? And those companies were selected because they were considered, they had the reputation of being expert in project management. And if you were in or around the United States in the early 90s, you would know every name of those companies. Yeah. So what I discovered was the gross average PPC for those companies was very close to Philip's, 54%. Yeah. Okay? So I would invite you to put yourself in my shoes and try to empathetically try to think about, well, how would you have reacted to that discovery?
If I can do what you've asked and interrupt you. Is this measured, is Philip's measured to the day?
No. Well, yes, Philip's measured to the day. Right.
So saying that this is equivalent to the early 90s research isn't quite correct because that was measured to the week.
That's true. That's true. But how would you have reacted? Yes?
Sorry to interrupt, but we need a microphone to be able to answer the
I see, okay. Okay, what I will do is repeat the question. Okay? Otherwise, we wait forever while the microphone goes around. Right? Yeah. Okay.
So do you want to repeat the question?
Okay. Well, Alan made the point that the early 90s research was based upon, it was a very generous allowance. I said, if you get it done during the week that you planned it to be done, that counts as a yes. And even then, it was only 54%. Okay? So, I didn't realize right away what I had found, but I had a sense that it was important, right? But it wasn't a measurement that was available. I couldn't find comparative data. I went to multiple companies. I went to Union Carbide. I went to DuPont. And I said, what's your experience with this metric? And they didn't have any, right? So what I came up with was the idea that it's a missing gauge in the project management cockpit. Yeah? And it's a measure not of productivity, not of progress, right, conformance to program or speed, but rather of workflow reliability. That is the predictability, the extent to which a weekly work plan made as near in time as 5 or 6 days ahead is an accurate predictor of a future state of the project. Yeah? Now, why might that be important? What I would suggest is that and it took me a little bit of a while to figure this out, but finally the dime dropped. And if David is dependent upon me for something he needs to do his work tomorrow or next week, and I'm about a coin flip reliable, my bet is that David will stop investing in planning and preparation for doing the task I'm releasing to him. Yeah? Because he's rational, I think. Do you understand that? Right? So it occurred to me at the time, and I still believe this, is that I think it's probably much more complicated, but this fact alone is sufficient to explain the decline in construction project performance relative to all other industries. In the last 20 years, construction productivity has declined, while in all non-form, non-construction industries, it's doubled. Yeah. So something systemic is going on, and I think this may be it. The normal way we manage projects discourages planning and preparation. How about that? You're awfully quiet. I don't know. Okay, but let's look at some other features of this. What is what? Oh, that just means those are the days in which they're expected to do that task. No, it's not a quantify. It doesn't quantify capacity, because the capacity is actually stated here, right? 3 workers, right? Okay. So on Monday and Tuesday, they're going to do that task. Then Wednesday, Thursday, Friday, Saturday, they'll do that task. So what he asked was, what's the X's mean? Any other questions about the graphic? Nope. Okay. So let's look at why these things failed. And we have here a change in the engineering design, right? So the guys pulled up their leads, they built a scaffold, they staged their materials, and an engineer happened to walk by and said, don't you know we've changed the elevation of those hangars, those prefabricated hangars? And this is really what happened. And they said, well, no, we don't. If we had known that, we wouldn't be doing all this work, right? That's going to turn out to be useless. Right? And I subsequently went to the design team, and I said, when did you know you were going to make this change? He said, we've been thinking about it and working on it for 6 weeks. Okay? So it's preventable, but it's ordinary. Right? It is ordinary and preventable. This is obviously a knock-on from that one. Yes, sure.
These resource of variances, how many different types do you have at that time?
Well, here we weren't using categories. I was just asking them to identify what happened. You know? Right. People often use like 8 different basic categories. I mean, if you think about a construction task and what you need in order to do it properly, then there's design information, which can take the form of original issue design, submittals, or request for information, right? There's materials of different types. There's workspace. There's a safety plan typically required, right? There's the skilled workers. There's equipment and tools. Right? Weather's not actually something you need, right? It's just something that might mess you up. You may need to protect yourself from weather. Yeah, that's true. Yep. But even when you're using categories, categories can conceal as well as reveal, right? You might say it's a materials problem, as we will see here shortly. But whence the problem, right? Did the foreman forget or fail to order the materials in time? Was it a bad delivery, a late delivery, or a missed delivery, or bad quality? What was it, right? And you don't know just by the category. So the category is like putting I'm from the South and from Texas, and we have an expression, putting the dog on the scent, right? And the category is just where you launch your dog. It's not the end of the trail, right? So, okay, so let's talk about this next one. So this one is material from shop received late Thursday. And you can see they were supposed to start this work on Thursday morning. So they lost a day, right? And they couldn't make it up even working overtime or adding capacity because some critical pieces of material were shipped late, meaning in the next, after that planned period, after that week. Yeah. Interesting discovery here. We collected this data working with this company and they had different, multiple crews, pipe fitters, sheet metal workers, plumbers, right, all of them were working in this project. And we collected the data for 6 weeks, and then we looked at the reasons for planned failure, right? 70% of the planned failures, right, what would warrant a no, had to do with materials. And I'm not saying this is representative. You've got to look at each case individually. But in this case, it was materials, right? And 90% of that 70% concerned materials from their own shops. And as my mother would have said, let this be a lesson to you, right? So very often people say, well, sure, my PPC is going to be low because those guys over there, they just don't do what they say they're going to do, right? And those people over there don't do what they say they're going to do. But in fact, the facts show that the vast majority of planned failures are well within our own power, okay? Maybe not directly, but indirectly. And in this case, this company is a very, very, very good company. They are rated among the top employers in the United States, regardless of industry, every year. When they saw this data, they were very embarrassed. Yeah, very embarrassed. But it didn't take too long, and with a little prodding, a little suggestion, for them to see the advantage. They says, this is within our power. These are our own people. This fabrication shop is in Dallas, in the same city in which our project's located. Let's go there and work this out, right? And they did, with our help. And in another 6 weeks, materials had almost disappeared as a reason for planned failure, okay? And as you can imagine, in a wafer fabrication plant, it's highly mechanically intensive, mechanical and electrical intensive. And so during the period in which they were the dominant trade, and that's a long period in such a plant, they ran the project essentially. Because they were doing 6-week look-aheads, they were producing reliable weekly work plans, they were actually working to learn from their failures, right, and not repeating them. And other companies came to their trailer to observe their planning sessions. Totally informal. They had no formal authority, but they had enormous influence, right? And for those of you who care about money, they wound up with a 31% gross margin. That's pretty good. I mean, I think it's pretty good. Okay, so moving right along. That's case one. Ready? Okay. This is case 1.1. So it's this is actually from a different project, but I was able on this project, or my graduate student was able to get both PPC and productivity data for individual crews over the period, the life of the project. Okay, so numerous weeks. And so what we were able to do was to plot the relationship between productivity here and PPC here. Okay, and that's the cluster of, that's the data distribution. And when we drew a line of best fit through it, then we could translate that into an equation, and then we can substitute in the equation different values for PPC and predict performance factor, which is productivity expressed as a percentage of productivity budget. Okay? So if you're expecting to produce 1 unit of product for 1 man-hour, 1 labor hour, that would be a 1, right? And if it's better than that, it would be, you'd be spending more. If it's better, you'd be spending fewer hours for a unit of product or of output. If it's better, you'd be spending more. Right? So this is, it's a variant of the earned value system. Is that a term of art? Do you recognize that expression? No? Okay. Well, it's a way of integrating schedule and cost in a single metric. Okay? You earn hours based upon your productivity estimate, your unit rates. And those hours accumulate into 100%, and when you have 100%, you finish the project. Yeah? Okay? So, what do you see in this number, in these numbers? No, it's in terms of percentage of budget. But it's money, right. It translates into money if you apply wage rates, right?
Quantity of job is not necessarily reflects of quantity. There are some tasks that they need a lot of work, and they don't represent so much money.
You mean in terms of what you get paid for it, right? Yeah, no, it won't necessarily correspond to revenue. Let's just assume revenue is fixed, right? It's a fixed price contract, right? Well, I was talking about cost. What's the cost of doing the work, right? That's what productivity really concerns, right? Okay, so anyone else? What do you see here? Okay, all right. So what I've done is I've put in for. I'm sorry?
The productivity, how can we read it well? I don't understand the graph.
No, the graph. You mean this graph?
No, the line.
The table? Okay, so this, I'll tell you how I got the table. I took 50% for the value of PPC, I substituted it here, and calculated productivity.
And the productivity can be read well?
Sure. Well, your performance factor can be greater than 1. In other words, performance factor, if you're on budget, your productivity budget is 1. If it's greater than 1, you're spending more hours than you expected to spend to generate a unit of product, right? If it's less, less. So what this says is that for a PPC of 50%, we're forecasting that your performance factor is going to be a 0.96, which is almost budget, right? A little better than budget. Huh? And what does that say? That says that the industry, if this is representative, budgets productivity at a PPC of 50%. Yes? I mean, this is enormously important. It's not a surprise based upon the original research findings, but it's revealing, right? Because it tells us, it's an indicator of the potential improvement we have simply from making work release more predictable. Not to mention technology, not to mention improvement in skills, not to mention improvement in work methods, right? All other things you can do if you have reliable release of work. Yes? Okay. This is really important. Yes?
So you're saying every PPC over 50% will make you win money?
Of course. Well, look at this. If you had a PPC of 80%, according to this formula, you should be operating at almost 30% below budget. That means your costs are, $3 out of 10 less, right? Would anyone like for that to happen on their projects? Yeah, of course you would, right? Well, here's a way to make it happen. Improve the reliable release of work, right? Okay.
One question.
Yes.
That works if you are very sure that the 50% PPC is correct calculated.
Well, you have to, the numbers can be, you have to have good quality data, right? And we didn't just allow this to happen. This was a facilitated project, and so it was very controlled, and we did have good quality data. Right.
Yeah, because it could be the misunderstanding that if I get 80% or something and the data is not really correct, I mean, I will be in the wrong position to think about that.
Well, the problem is you wouldn't be able to draw conclusions from your correlation analysis, right? Because you would have screwy data, right? So data quality is important. Point taken. Yep.
Sometimes the problem is that you produce more than you expect. And then the PPC will increase, but your productivity will increase. If you are conservative, it's conservative. With the forecast,
Yeah.
it happens also.
Sure. Well, I mean, all
Change all this, basically.
all systems can be gamed, and you can't prevent it, except by persuading the people who can game it that it's not in their interest to do so. That's the only way, right? So.
But I also think that the main point here is that people are putting budgets expecting low productivity. The lack of trust in the industry that definitely what's the industry.
Well, expecting low, no, what I would say, Paolo, is that they understand productivity. The norm for productivity is based on a very low expectation about workflow reliability, right? And that's because we haven't previously understood the causal relationship between the two, right? The cause-effect relationship goes workflow reliability, productivity, right? You don't work on productivity directly or immediately. You work on making workflow reliable. Then you can work on optimization. Yeah? Okay? And I will show now an example of that. Okay. Okay. So this is from a project in Venezuela. It's a refinery expansion project that was the budget for which was $1.2 billion US dollars in 1994. So, a pretty big project. And they were running out of ground, and they were way over budget and way behind schedule, 1 year from schedule completion, right? And they had 10,000 workers on site, big project, and they calculated based upon their their history, that they needed 18,000 in order to end on time. There weren't 8,000 additional people who could tie their shoes available, right? And there wouldn't have been any place for them to stand if there were. So they didn't have any option except to improve productivity. And that was good for me because I got the job, right? So, and it turns out it was good for them, right? So this is from one. There were a number of. It was a big project, and it was broken up into multiple packages. There were 15 major contractors. Okay, and we went to work with those 15 contractors. And I'll just divert for a moment. Someone just yanked the mic out of my hand when I run out of time, okay? That was a joke. So I walked on the project, I get the obligatory tour, and, you know, I've just been told they're way behind schedule, way over budget, and half the crane booms, the lattice boom cranes, are on the ground. Half of them. And I say, what in the world's going on? I thought you were in a hurry. And so I went to talking with the contractors, who were all Venezuelan registry by law, right? Even though they were all basically European companies. And they said, it's a problem of cash flow. We get paid so slowly, and we need dollars in order to get replacement parts. Yeah, hey, it's real world, right? I'm sure it is. Well, so what I did is I went to work with PDVSA's, Petróleos de Venezuela's accounting office. And I worked with the head accountant, the head of that group, and we mapped the process, right? And luckily for us, for me and for them, I discovered a hinge that allowed me to fold it over, right? So I could do concurrently rather than sequentially, right? So if you look from your perspective, it went like that, right? About here, I realized that I could take it like this, right? And so it went like that. And so we cut it in half. I was immediately persona grata by all contractors, right? And that was the lucky, I just got lucky, right? Sometimes you get lucky. So, but one of the things, we did two things basically to help them recover. And they did recover. We wound up improving productivity 28% in the last year. And we completed all but some incidental systems and units that they could, without cost to themselves, significant processing cost, add in later. But we did it by implementing the first level of the last planner system, and then working with the direct trades to improve the design of construction operations. Okay? Okay? And this is an example of what we did with Last Planner. So again, we've got performance factor, where 1 is budget. 0.5 would mean, again, that we're spending half of the budgeted labor hours to produce a unit of output. 1.5 means we're spending 50% more than budgeted labor hours to produce a unit of output. You can see that over a relatively short period of time for this process unit, this is 1 of 15, their productivity degenerated to almost half again budget, right? Almost 1.5. Yeah? We intervene with the base level of Last Planner, and I'll try to explain what I mean by that. So the first thing I worked on in developing the Last Planner system was the problem, how do I improve PPC? Right? That's not the only thing you want to work on, but that's the first thing you want to work on, because that creates reliable space, right? A pool of calm water. Right? So, and the way to do that, and you can see that's where we did it, and the impact was almost immediate. So what this shows is reported productivity every week. You can see that that was high, right, and erratic. And it got better and tighter. And then the impact on the cumulative is shown here, where it was rising. This company, Formiconi, which is a subsidiary of an Italian firm, predicted, they said we would have wound up at a 2.5 if we hadn't intervened when we did. Okay? They wound up actually at about 1.32, which is not great, but we ran out of project. And I think the graphic illustrates one other very interesting phenomenon that I don't know if it's a general principle or not, but it may be. Things get worse faster than they get better. I hope that's not always true. All right. But you can see that if any of you have ever had the challenge of reversing a negative trend in productivity on a project, you probably agree with me that it's very, very difficult. Once the horse gets out of the barn, it's hard to get him back in, right? Because you get bad habits, things just go screwy, right? And in this case, we were able to do it, right? Now, building on, let me just explain, began making quality assignments. So quality assignments, I was, my task in developing the last planner system, the first task was, how do I increase the match between will and did? What we say we're going to do and what we do, right? That's what PPC is, right? And I proposed 4 quality criteria. One is that we only allow on weekly work plans tasks that are sound. That is, their constraints have been removed or are in our control to remove. Yeah? So you got materials, workspace, right? The second one is that the work is done in the proper sequence so that we're not doing something now that's going to cause us a greater penalty later. Right? So when you're thinking about, I can't talk without my hands. How do I do this? Can you hold this for me?
No. ¿Sabéis dónde está el que está haciendo ruido todo el rato? Hay uno que se está yendo muchísimo, ¿no? Vale, pues nada.
Can you hear me now?
Yes.
Is that all right? Thanks. Okay, good. Okay, so where were we? Oh, yeah.
Do we have an example of the first 4 criteria?
Juan.
The one that removes the constraint?
Well, you mean what a constraint is?
No, I mean an example of what you mean of this point.
Yeah, you were talking about 4.
Yeah, the 4. Okay, well, the first one was soundness, right? Is the task sound? And that means we've got everything we need in order to do it properly, safely, to quality criteria, to cost targets, and to time, right? And an example of that was the example on Philip's weekly work plan where he didn't get the materials that he expected to get, right? So that's a constraint that had not been removed even though he thought it had been. Right? So soundness, then sequence. And if you're doing work out of sequence, I can tell it's very quick. I'll try and do this quickly without speaking rapidly. Went to a different project, again a refinery project for Union Carbide in Texas City, Texas, one time or other. And I was walking through the project with the construction manager, and I heard a sound that I recognized because I used to make that sound myself when I was working as a pipe fitter. And what's that sound? Anyone know? It's the sound that's made by a ball-peen hammer hitting a piece of number 9 wire wrapped over a broad flange, right, on a beam. And you're doing that to do what? To create a temporary hanger. And why would you do that? Because you don't have the permanent hangers. And why would you install it without the permanent hangers, even though you know it's going to be a hell of a lot of cost and time and effort to fish those permanent hangers back in through that nest of wire and stuff and pipe that you're building? Why would you do that? Because you get paid for it, right? You get credit, right? You get credit towards project progress for erecting a pipe spool, even if it's on a temporary hanger. You don't get the credit for the hangers yet, right? That's why that whole system's been changed since. I hope it's been changed here too. Oh, maybe not. Maybe not. Okay. So that's sequence. So when you're thinking about a weekly work plan and eligible tasks to put on it, you have to think into the past in order to understand whether it's sound. Have its constraints been removed? You have to think into the future in order to understand whether it's in the right sequence, right? Should we do it now? And we're often pushed to do work out of sequence because we don't want to lose capacity, right? We don't want to lose labor capacity. And we're looking for ways to avoid that, right? So there are many incentives that are systemically destructive in our normal way of doing work, and that's one of them. Yep. Okay. Okay. And then the third one is size. And my thought there is that if we're really trying to be predictable in the release of work from one party to the next, we shouldn't be sizing tasks based upon budget unit rates, but rather on the basis of the capability of performance of the people who are doing the work. Right? Okay? I may not be as fast as Paolo, right? So don't expect me to do that. Work with me to develop my capability, coach me, train me, teach me, but right today, I can't do 20 feet, I might do 15, right? But I would expect 20 out of Paolo. Yeah? Okay. Okay. And then the fourth quality criterion that I proposed was definition. That the task should be well defined for the person who's going to do the work. So by looking at the description of the task, they should be able to tell what work is to be done, when it's to be done, where it's to be done, and to be able to identify what's needed in order to do it. Right? They can find the materials. They can.
You mean scope of work?
I mean the task itself.
The task, okay.
Right, the task itself. Right. And if you think back to that weekly work plan of Phillips, those were pretty well defined for the people on the job. We might not know where to find the materials list, right, or what's the list of what's in the laydown yard, but they do, right? So what we see here is the impact of those very simple rules. Very simple rules, right? Yes. Here we go.
The cumulative value of the performance factor, or as time goes by, trends to the middle of the function.
Sorry. That wasn't a comment.
It's not our lucky day. The function, the cumulative values, trends to the middle of the function as time goes by. But the variability of the function, the value of sigma, is important too. But how can be easily so in this function? The value of sigma, the variability, the deviation of the function.
So you're asking about variability, but I'm not. Variability of what?
The variability of the function, the performance, the cumulative value, obviously, as time goes by, it tends to the stabilization.
Well, what I'm saying that this shows us,
but the variability of the PPC, the PPC may be can have a lot of variability, but the middle never changes. How can we express?
Are you reading the graph right? I'm not sure you're reading the graph right. These are all above 1, which is budget, right? So it's dragging the
variability of the
total up, right? The cumulative, right? It's the variability in productivity, reported productivity. So it's bouncing around, right? So here it's really low, 2.5 times budget. Here it's better, 1.6 times budget, right? But it's still way above budget. So it's dragging up, right, your cumulative productivity. rate.
But the variability don't affect to the middle of the function. When you target to the stabilization, the deviation of the function, the value of sigma of the statistical function.
It's not going to affect this number here. No, it will of course have an effect upon the downstream, the release of work, right? Because they're releasing different amounts of work into a relatively stable system, right? So it's like a mouse going through a snake, right? Yeah. Does that help? Mouse going through a snake and it didn't work? Okay. Okay, someone else had a question, I thought. Okay, so what I'm saying is that I'm just showing an example of how we used Last Planner on this project, even in its simplest form, the first application level of Last Planner, to increase workflow reliability and mute variation in output, right? And that created the conditions for optimization. And we did that by working directly with the craft, the trades, on specific construction operations, right? And this is just an example. We persuaded almost all 15 of those contractors, the major contractors, to buy video cameras for their foremen. And, right? This is Venezuela, right? And they were not accustomed to foremen having video cameras, let me just tell you that, right? But it worked a charm. So we had representatives from each of those 15 companies that worked with us as they were engineers, and we taught them how to do methods analysis and methods improvement so that they could teach others, right? And we worked with them to spread the word. But what happened, we lost control of it, thank goodness. It wouldn't have worked if we hadn't lost control. But within 6 weeks or so after we launched this initiative, this work methods improvement initiative, I could walk through this process unit in this massive refinery and see a new method of pulling cable, right? Hadn't seen it before. It was an invention. Someone figured it out, right? The next day, I could go to the other side of the project and see an entirely different company, different individuals doing the same method, right? And what was happening was the trades were getting together, the foremen were collecting by trade in the evenings and sharing their discoveries. Yeah? It became a learning community. And that's what made it work. Okay? But look at some of the improvements, right? So ATA was doing pipe supports. They went from 3 a day to 22. Costa Norte installing large cooling water pipe, 54-inch diameter. We're doing 1 unit in 4 hours and 19 minutes. They reduced it to 32 minutes. Dane Spee installing, doing terminations in junction boxes, right? Little tiny pieces of things, right? They were doing 1 wire every 5 minutes. They went to 1 wire every 3 minutes. Distral, 10 piping isometric drawings a week to 15, and so on. So you can see here there's a wide range of trades, different types of work going on, and they had been doing this work for 3 years prior to this intervention. So this is not learning curve, right? This is invention curve. Right? They were reinventing the way they did the work, right? And they all got really excited about it. And what the message I'd like to send here is that don't be satisfied with getting just a little improvement from Last Planner. The real importance of Last Planner is to provide the stability within which innovation can occur. Don't miss the opportunity. Okay, a different case. How am I doing on time? We're okay? Okay. Okay, so I'm switching to a different case. This is from the UK. This is a precast concrete factory, and they produce both architectural and structural precast elements. Right? Stairs, columns, beams, walls, floor sections, so on. Yep. And I was brought in to help install a production cell structure in this factory. So what that means is that we wanted to have, to the extent that we possibly could, have independent resources for each of the production cells and to organize the cells around the production of product families that weren't necessarily identical piece to piece, but were sufficiently close that the difference in labor content was overwhelmed by the benefits of that mode of production. Okay? And specifically, so I chose first thing I did was I went through the project and I just made observations and times and that kind of thing. And I convinced myself that with existing technology, existing skill levels, we had the capability of going at least twice as fast, doubling productivity. Okay? Then I asked Nigel Harper, who was the factory manager, I said, Nigel, I want to meet with the workforce mafia. And he said, what's that, mate? And I said, it's the people in the project, whether they're in supervisory level or not, who control opinion. And we need them on our side or off the job, right? One or the other, right? I'd rather have them on our side. So let's give them that chance. So they identified 5 different individuals, brought them in, and we shared the financial information about the project, about the company, which was pretty dire, right? And we said, we have to make a change. And you can have a voice, but you don't have that choice. That choice has been made. We're going to make the change. But we want you to help us do it. We need your help to do it. We did some games, like some of you may know the airplane game, which is a production system design game. We did all kinds of things. And then I selected 2 of those guys to be the leads of 2 pilot production cells, one for floor elements and one for shear walls. Okay? The guy for shear walls had been represented to me before that meeting as the crankiest, orneriest, most belly-aching, naysaying guy on the job. Yeah? And what actually turned out to be the truth was he was really annoyed and disgusted with the low level of professionalism and the poor quality of output. So I said, okay, you're my guy. You're my guy. We're going to work on the shear walls production cell, and we're going to figure out how to do it. And we're going to take it from 2.3 walls per day to 9. Yeah? That was our challenge. And we did it. Yeah? So, this is not a very technologically sophisticated operation. Perhaps you can tell just by looking. Right? And it wasn't optimum. There's a lot of other things to be done besides what we did, but I thought this was the starting point. Okay? So, here's what we did. We went from, there's a change in workers because Nigel, the factory manager, said, I think you need 2 more iron workers, steel fixers, in order to hit the target. And I said, I don't think I do, but I'll take them. We'll track it, and if I don't need them, I'll give them back, right? So in the first week, we went from 3.2 a day to 6 a day. I gave the 2 guys back, and then the next week, we hit our target of 9 with the original 12 people. All right? Okay? So, how did we do it? This is a busy, busy slide, and I apologize for that, but I want to just show you some of the, take a look at it. There's a lot of information here. This is a value stream map, right? And value stream maps go from the customer and their orders, their request, through a control function, through suppliers providing materials, information, and so on that you need in order to do the work, and then through the production process that produces the product to the customer order and delivery. Yeah? It's a circle. Right? So I'll just point out a few little things. This is a relatively simple process, right? They cut and bend the steel that's going to go in the boxes, in the forms, right? There are couplers that have to go in there as well, and they're made in a separate fabrication step. And there's carpentry work to build the wood end pieces that close up the mold. And mold is the British speak for form. Yeah. Are you with me? Okay. And and then the next step is to tie those cages together, so from the cut and bent steel, and to put the cage in the mold, prepare it for pouring, in part by closing up the ends, right? Place the concrete, cure it, strike and clean the mold returns this way, and the stone, the precast element, goes out that way. Yeah? So is the process clear, at least clear enough?
Yes.
Okay, thank you. That's what I need to hear. I need reinforcement. Okay, so but look here, we've got released the next 3 drawings. Okay, so what I had 3 two-person placing crews. So the way I understood that in my head was I had a gun with 3 barrels, right? And I divided the workday into 3 parts, 4 parts if you count overnight curing, right? And I structured it so that I needed one, so I have one stone in each of those barrels, right? And every third of a day, I needed it the work to go to the next step, right? 3 times 3 is 9. Right? That's how I got it. It's a demand-based structure. Right? So another thing I want to point out is that we have here an instance of push. They didn't ask for they are asking for the next 3 drawings, but they're not asking for these next 3 drawings. That's based upon the understanding between the customer and the factory. Right? So that's push. So we're releasing work from one specialist to the next based on push. Then we have pull, right, here and here. And an example of pull was I told the steel fixers, I want you to make the next 3 cages, put them right there in front of the boxes where they're going to go, and stop. And they said, are you trying to get me fired? Right? Because we've taught people to look busy even when they shouldn't be busy, right? And we need to stop it. We need to stop it, right? So what can you do? Well, you can rest, you can clean up, you can do problem solving, right? You can look at, well, what things have been going wrong that we might be able to fix. There's lots of useful things for you to do, but by God, do not make another mat, right? Don't do that. So that's pull. And then we have here a sequence that's really continuous flow. Now, it wasn't continuous flow when I got there. They were batching because there's an expense to produce. There are 3 batchers on the project, or in the plant, 3 concrete batchers, right? And there's some expense to making a batch, right? And so there was resistance to making small batches. And I said, get over it. Get over it. I want, every time a box is ready to be filled with concrete, I want it filled right then, immediately, right? Okay? Overtime disappeared, right? And productivity exploded. So that was kind of a false economy. But what we've got here is, in even this modestly complex, relatively simple, production system, we have all three mechanisms for the release of work between specialists. Push, pull, and flow, right? So my advice, and don't take any advice without being thoughtful, but my advice is flow when you can, pull when you can't, and push when you must. Okay? So, okay, this is the impact on Malling's revenue when we roll this out beyond the pilot production cells to the entire factory. This was their average revenue per week for the previous 18 months or so, which was about 130,000 British pounds sterling. And we intervened here. It jumped up almost immediately to double that, 260,000 pounds a week. And in another 6 weeks, it leveled off at 330,000 pounds a week. The cost for doing this was, apart from consulting fees, was 25,000 pounds for a screen to protect the workers from the fumes of an acid bath, which I insisted be put in. Okay? There's lots of other things that need to be done, but this was done without changing workers, without changing skills, without changing tools or technology. They're still cutting, bending, placing, curing, exactly the same way they always were. The only thing that's changed is workflow, the structure of the work, and its control. It's being controlled directly by the workers by following simple rules. Yep. Okay? One more. Oh, two more. Do I have time for two more, or should I skip one? You sure? You sure? Okay, this is the Terminal 5 project at Heathrow Airport. And this was in the early 2000s. About 2003, probably, this picture was taken. This is underneath the main terminal building. And you can see there are there are two holes in the wall back here, which are tunnels going back towards London. There are two rail systems, the Heathrow Express and the Piccadilly Underground line, that terminate right in here, right? So, and you can also see there's a tremendous amount of prefabrication. You don't see any precast concrete, I don't think, but the precast concrete is coming from that company that we were working with just now. Yeah. And I wanted them to be able to produce it to quality standards, on time, right, and to cost. And we had, these are roll mats, which are, we built a rebar factory on site because the amount of steel we were going to use in this project would have distorted the pricing in the UK market. Okay? Right? So we got, in some sense, we really got lucky. This project was so challenging that it allowed us to do things differently. Right? So the client is BAA. They were previously a public entity, British Airport Authority, but when they were privatized, they just went to BAA. And BAA was faced with really dire financial consequences. If this project had been completed, were to be completed on budget, that they would spend 75% of their net worth. The history of public projects, especially heavy civil projects like this, in the UK gave them a trepidation, right? They were betting the company. It could easily have wiped them out, right? In the face of that risk, they did something really unusual. They threw the lever in the opposite direction to what you might expect. Instead of getting more conservative, trying to shift cost risk, they took it all on themselves. They took all cost risk. And they did that to get all control, right? And then we helped them manage the project. Right? So it's very highly prefabrication oriented, and obviously that last planner is the operating system, if you will, underneath all this. as we were getting close to starting construction, we started working with them in design. But as we started getting close to construction, we realized that we weren't going to be able to hold the construction schedule, the program, because we weren't getting detailed engineering drawings for reinforced concrete structures fast enough. Yeah? We did a map to the top one here, and found that in the existing process, it was taking about 6 weeks to generate engineering detail drawings. Okay? So we used that, and we figured if we could persuade the client, and we did, to convert the 2D structural design into 3D, we could detail in the 3D model just in time and hold the schedule. Yeah? And we did. Okay? So the model that we used, or the modeling software we used, was really a mechanical engineering software, and we wanted that because we wanted the ability for parts explosion, right? Because of the high focus on pre-assembly. Right? And traditional civil engineering software doesn't do that, right? It's accretions, right? Instead of plugs. So for those of you who know, it was a CATIA-like software. It was Ideas is the name of it, and there's 3: Pro-E, Ideas, and CATIA are the 3 major ones, and we were using Ideas. So what that enabled us to do, we trained 19 construction engineers to do modeling in Ideas, right? We paired them with a structural engineer. We were co-located with the structural engineers. And so we had a modeler, a structural engineer, and somebody with tattoos on their arms, right? Okay? Who actually knew how to detail a reinforced concrete structure so it could be built, right? And we figured when those guys had their say, that no one else needed to talk. But it allowed us to pull detailed engineering to the pour, to the concrete placement. Yeah? So instead of, where you might think of it is, instead of detailed engineering being the last act of design, it became the first act of construction. Yeah? That's the kind of innovation we're looking for, and is possible in Lean. Right? You're wrinkling your brow. Oh, you don't. Just good. Okay. So here's how we set it up. So in the Last Planner software, we would plug in a date for a pour, for a soffit or a slab, a wall section, something, right? And then, or a foundation, and that would populate back in through the chain of tasks to the detailing team, and they would say, they would then know, by this time, 2 days ahead of placement, we need to have completed the detailing for that structure, right? Then we allowed 1 day for cutting, bending, and pre-assembly at the rebar factory, which was just a couple of kilometers from the site, right? And then we we allowed 2 days for installation on site. And we allowed 2 days initially, even though it only took 1 day to do the work. So, any thoughts about why we might have done that? That's an unfair question. So what I realized was that initially the people installing, placing mats, building forms, placing concrete and so on, they were going to be highly skeptical of the ability of the supply system to provide them what they needed when they needed it, because they hadn't had that experience very often, right? And so I said, let's start with the rule, we deliver today what you install tomorrow. And the consequence of that was that when they walked out of the job every day, they walked past what they were going to install the next day. So there was no question about no reason to temper pace to match supply flow, right? Which is very often what happens. Right? Yeah. Once we got their confidence, we took another day out of this process. Right? Okay? So if we add it up, we have 2, 1, plus 1 for installation. Right? So a 4-day cycle. Right? Now, being able to go that fast because of concurrency allowed us to overcome some challenges in the schedule, in the program. Don't need to build on this, I don't think. So for Railbox East, which is a part of that tunneling system, the cut and cover portion of the rail system, that we looked at on that first picture, it was on the critical path, was way behind schedule, and needed to accelerate. Originally, it was expected that they would begin earthworks basically on the 9th of September 2002, right, and complete the pickaxe launch chamber, that's for the tunnel boring machine going back towards London, right, on 12th September 03, right? But as it happened, as things happen, they didn't start earthworks because of design delays until 24th of March. So that's 3.5 months, right? 3.5 month delay, right? But we were able to make it up because of the new process that was installed. So just to cut short. So we recovered to the original date, even though we were late starting 3.5 months, and we saved on-site steel fixing labor of above 776,000 pounds. Okay? There was other labor in the rebar shop, of course, right? But the net was positive for productivity. And this is from an industry paper published at the end of the civil phase of the Terminal 5 project. So, first major UK civil project in the last 40 years to be delivered on time. Not my words, their words, right? $125 million cost savings, and that was split 50-50 between the members of the project team, except for consultants, and the owner, right? So, can I do one quick one? I got one quick one, okay. Okay, now this brings us up to almost to date. So now finally we're talking about buildings. And I think most of you work in buildings, is that right? Yeah. All right. But one thing I wanted to do was to show that lean applies across, it's not just about buildings, it's actually not just about construction. Right? It's about lots of things. But here we're talking about healthcare buildings, so clinics, hospitals, right? And a company the largest healthcare company in Northern California is called Sutter Health. And last August, I asked Sutter Health's chief architect and chief planner to come give us an update on their experience with lean project delivery. They committed in 2004, I think, or maybe late 2003, to deliver their capital program using lean. Their first such project was completed in 2005, and since that time, up to last August, they completed 22 lean projects above $10 million. And as you can see, all of them completed within budget and schedule, no exceptions. The client is reporting there was no sacrifice of quality or scope in order to get those cost and time outcomes. And cost at completion averaged 3.4% under budget, and budgets were set aggressively. We have market benchmark costs for about half of these projects so far, and I'm trying to get the others. But if we just look at that half, they were averaging 15% under market. Okay? This is an example of one such project. It's since been completed. It completed last October, I think. It's a replacement hospital project in the Bay Area, Eden Medical Center. And here's just some interesting data about that project. This is, of course, what we've already seen, ahead of budget, schedule. In fact, they were 6 months ahead of schedule. No compromise to space program or sustainability. Look at construction rework was 15 to 80% less than trade baselines, depending upon the trade. So for some trades, 15, some trades, 80. Productivity, 5 to 20% greater than trade baselines. And there was a intense focus upon building to the 3D model, right? And so this mechanical and plumbing won the prize for that. They were installed exactly to the model 99% of the time. And I'll show you a picture that illustrates that in a minute. And down here we've got fewer RFIs, change orders, failed inspections, and tool time significantly higher than industry standards. And tool time is a measure of labor utilization, right? The percentage of paid labor time spent productively. And on a normal project, 40, 45, 50% would be a very good number. It was 70% on this project. Okay? And here's the comparative picture. Okay, boom. Sorry, did I end too soon? Sorry to overrun. Questions, comments? Do we have time for anything?
Yeah.
Okay.
But if no one asks, I'm going to ask.
No, go ahead.
What everyone's thinking. What if the project is it's not that huge budget, over $10 million?
Sure.
Do you recommend it? Do you still recommend all this?
Yep. Yeah, I'm working with a large contractor in Scandinavia, and they have a residential business line, and their typical residence is an apartment building with maybe 12 flats, 12 apartments, right? And we're using lean on those, and with great benefit. So I don't really know why you wouldn't. I mean, you can use lean to clean this room, right? I mean, so it's not really a question of there's no size limitation, right? It's just what's your problem and what's within your power, right? So.
What's your expectation?
Sorry?
And what is your expectation to improve?
Yes? Yeah.
Sorry.
If not, they can.
Yeah, and what is your expectation to improve? I mean, that is the boundary, I mean, actually.
Right. Yeah, if you want to improve, then I don't know why you wouldn't be exploring what other people have learned and developed and then inventing more things for yourself. So. And that's what lean's all about. You know, it's not a church. It's not a church. It's not a canned set of tools, right?
After you make last planner system, I mean, the very first time that you publish your work, which would be the next big step up in the last planner that you already discovered?
I mean, that's yet to happen?
Yeah.
God, if I knew that, I would do it.
No. I mean, you invent last planner system a few years ago.
Yeah.
After that, which should be the best upgrade of last planner that you already performed since the very first
I mean, the
version?
best application?
Upgrade. I mean, the best movement up to improve your own last planner system.
Well, there's huge amount of things that have improved from the early days. I mean, I gave a report on that. It needs to be updated, but there was a last planner update that I published in 2005 or something like that, where I talked about, well, what innovations had been made, right? And I mean, one of the things, of course, is There have been a number of different types of software used for instantiation of the system. And if you're doing big projects like these, then you have to have it. Right? But you just can't keep everything organized without it. I think that the big push, it's been approached, and I showed some examples here. One of the big pushes in Last Planner, it seems to me, is to push control down to the workers themselves, as opposed to having it always negotiated by a supervisor, right? And the paradigm for that, of course, is an assembly plant, right? The foreman doesn't say, okay, now let's move this car here, and now you're going to do a blue one, right? All that information is inherent in the system, right? And the workers follow rules about how do you manage that workflow, including stopping the line if necessary. Right? So that's a big push in Last Planner. But again, just to reiterate, I think Last Planner's importance is it creates the conditions, cultural and technical, for optimization. Right? And so exploit that opportunity. Yeah.
What's the relevance of the design team being involved in the weekly planning meetings, the weekly sessions? What happens? Because we have experience applying Last Planner without the design team sometimes having anything to do with it. Just the construction company with the subs.
But you're talking about in the construction phase of the project,
yeah.
Right? Well,
so do you have any experience of like a performance improvement by the design team being there or not being there?
Yeah, I don't think it was actually. Well, I came out of the industrial sector, and in the industrial sector, it's routine to have on-site engineering support during construction. And probably because we had to make so many changes. Right. But that seems to me to be.
So you always had
reasonable.
the design team involved.
Absolutely. Now, it may vary some depending upon what it is you're building, right? If you're building something that is essentially a copy of something that's been done before, you might not anticipate so much need for conversation between design and construction. But you got to find out by experience.
Okay. Thanks.
Mm-hmm. Anything else? This is your opportunity to ask the question you've always wanted to ask. Except, what's the best paella in Valencia? Because I don't know. I'd like to know. Okay. Well, thanks very much.
Thank you. Bueno, recordaros dos cosas. Una, que tenéis una comida para el que quiera asistir en la cafetería de la Bella a la hora de comer. Y para aquellos que mañana vengan a los días académicos, informaros de que justamente mañana tenemos una huelga. Así que si venís y hay algo de movimiento y no podéis entrar, pues os esperáis un poco. Y hasta que se pase el movimiento, que suele pasarse a la hora de almorzar, ahí a las 10, se van todos a almorzar y ya podéis entrar. Tenemos ahora un descanso hasta y 40. Venga, gracias.